Okay, this is MCQ paper 9702, paper 1-2, and February, March 2022. Look at this question number 21. A CRO, cathode ray oscilloscope, is used to determine the frequency of the sound wave. The diagram shows the waveform on the screen. The time-based setting is 5 millisecond per division mean. Horizontally, this box is representing time equal to 5 millisecond. So what is the best estimate of the frequency of the sound wave? So we have to get answer for this frequency. So first, the frequency is equal to 1 over time period, or number of the waves divided by total time taken. So for the time period, we will count the number of the boxes for one complete wave. So one complete wave is this. This is one wave. So this is approximately number of boxes. Look, 1, 2, 2.5, and the middle of this either 2.75 or 2.8. So 2.8 horizontally boxes are covered by the one wave, and one box is representing 5 millisecond. So time period is 2.8 or 2.75 multiplied by 5 millisecond, milli mean 10 power minus 3. So this is approximately the time period, mean the time taken by the one wave. Now, by using this formula, frequency is equal to 1 over time period, 1 divided by 0.01375, you will get this answer 72.7. So here the question is best estimate. So close to this is 71. So 71 hertz will be the answer here. And now move to the number 22. The warning signal on the ambulance has a frequency of 600 hertz. So this is the actual frequency of the ambulance sound. The speed of sound in air is 330 meters per second. Ambulance speed is constant and it's 25 meters per second. So this is the speed of the source, which is supposed represented by Vs. This is the actual frequency, and this is the speed of the sound. Towards the observer, first, the ambulance pauses and then moves away from the observer with no change of the velocity, meaning the velocity is constant. The question is, which overall change is observed frequency take place between the time at which the ambulance is a long way behind the observer and when it is long way in front of the observer. So first look, this is a fixed observer and ambulance is moving towards the observer. So for the towards observer, this is the observed frequency formula. F naught is equal to VF, actual speed of the sound, actual frequency, divided by V minus VS, speed of the sound minus speed of the source, mean the ambulance speed. So 330 into 600 divided by 330 minus 25. So 649 is the observed frequency by this observer when the ambulance is moving towards him. Now, at this position, the ambulance moving away from the fixed observer. So away from the fixed observer, this is the formula for the observed frequency. This is V, this is F. Now here it is V plus Vs. So 330 plus 25. So answer is coming 558, 558 hertz. But the question is, what is the change, overall change? So the difference of these two answer, 649 minus 58 is 91. So C is the answer, because we have to calculate the change in observed frequency towards the observer and then from away from the observer. And the next question number 23 is, brief pulses of red, blue, and the green light are emitted from sun at the same time. So they have different frequency, different wavelength, but do remember, all are electromagnetic waves. So they will travel with the same speed, which is the speed of light. The pulses travel in the same distance to reach the Mars. Assuming that the pulses travel in a vacuum for the full duration of their journey, in which order would the pulse of the light arrive at the Mars? Look, distance, speed into time. Distance covered by the all light rays, red, blue, and green is the same. They're all traveling with the same speed. So definitely they will arrive at the Mars at the same time. That's why the A answer, all arrive at the same time at the surface of the Mars. So B is wrong, C is wrong, D. So the correct option is A. Next number is 24. Two coherent progressive waves from different sources meet at a point. Suppose one wave is traveling in this direction and other traveling in this direction, okay? And both are meeting over here. Which condition must be satisfied for there to be a zero resultant amplitude, mean destructive interference? For destructive interference, there are two conditions. Both waves must be coherent, and definitely their path difference on reaching the meeting point must be n lambda. N plus 1/2 lambda for the destructive interference, where the wave. So first, the two waves must be emitted from their source with the same intensity. No. If the distance is different, the intensity on reaching the meeting point will be different, so amplitude is not same, because for the destructive interference at the meeting point, both amplitude must be same, but one displacement positive, other negative, so both will cancel. For example, this is 5 centimeter, this is -5, so then answer will be 0. It means the displacement at the meeting point must be 0. Resultant displacement. So the individual displacement, one positive, other negative, same in magnitude. But if they are traveling from the different distance, so definitely when we will have the same intensity, so they will meet with the different displacement. So A is wrong. The two waves must be in phase. No. When crest and trough overlap, the phase difference is 180 degrees. So for the destructive interference, zero resultant amplitude, destructive interference, they must be out of phase. And the two waves must be traveling. No. When they are traveling the opposite direction, the stationary wave is formed and there is no progressive wave. So the answer is D. The two waves must have the same amplitude at the point where they meet. So this is the correct option, D. Number 25. The corridor is 13.2 meter long and has a closed doors that reflects sound at both ends. So the sound is reflected from the hard surface, right? And the reflecting point is called node in terms of the stationary wave. The speed of the sound in the air is 330. What is the lowest frequency of the sound that could create a stationary wave in corridor with a node halfway along it, halfway node, and at the reflecting surface also node. So how many nodes are formed? Two nodes at the reflecting surface, one node given. So this is the shape of the wave. Now node to node distance, lambda by 2, node to node, lambda by 2. So this 13.2 is lambda by 2 plus lambda by 2, mean the wavelength is 13.2. Now in this arrangement, the wavelength is 13.2. So V is equal to F lambda, F is equal to V by lambda, V is given 330, wavelength is 13.2. So the frequency is coming 25. That's why this C is the answer. Next, 26. Water waves of wavelength lambda are formed in a ripple tank. The waves are diffracted and they pass through a narrow gap of width D. I mean, this is the width, the diameter of the opening. And D is greater than lambda. So when D, the opening size is greater than lambda, definitely there is a non-observable diffraction. It's hard to observe the diffraction. Which gap width and the which wavelength will cause the larger decrease in the amount of the diffraction? Mean we have to make it more non-observable. So definitely we have to increase this D. Number one option. Number two, if we keep this D same, lambda must be decreasing. And the third option is increase D and the decrease lambda, because we have to keep this D very large as compared to the lambda. So the distance, this gap D and the lambda D is greater than lambda for the non-observable, and we have to make it more non-visible. I mean, we have to decrease the amount of the diffraction. So definitely D must be more large as compared to the lambda. So it's only possible when we will take the third option instead of the first and two, D increasing and the wavelength increasing. Yes, first option, only increase D. Second option, decrease lambda. But here, look at these options. All are changing. Nothing is kept constant. Definitely, we will adopt this third one. So we will increase D, we will decrease D. So that's why this C is the option, D becoming double, wavelength becoming half. So it becomes more non-observable diffraction. Now look at this question number 27. Two loudspeakers, X and Y, emit sound wave that are in phase and the wavelength is 0.75. Wavelength is given. They're in phase. An observer O is able to stand anywhere on the straight line that passes through the X and Y as shown. So definitely the distance of the O from X and the distance of O from the Y is not same. OY distance is greater than OX. So definitely then this OY distance is greater than this XY distance. The observer stands at the point where the sound wave from X and Y meet in phase, mean constructive interference. What will be the distance OY and XY? So first, our observation is this OY distance is greater than XY. So it means A is not option, B is not, because here the OY is smaller than XY, OY smaller than this XY. So these are not options. So A and B not option. Now for the constructive interference, the path difference, and the path difference is OY minus OX. OY minus OX, which is equal to XY. So this XY is the path difference. Is this XY path difference must be equal to N lambda. So this XY is 2. This is not the whole multiple of 0.75, because when we will divide this 0.75 over 2, the number is not whole number. But when we will divide 1.5 by 0.75, the answer is coming 2, the whole number. That's why the D is the option. So A and B are rejected because OY is greater than XY. And C is rejected because this is the path difference and it's not whole times N times lambda. Whole number times lambda. This is not possible. So 1.5 is the double of the wavelength. That's why this D is the option. Now move to question number 28. Light of single wavelength, mean monochromatic light, single wavelength, is incident normally on the diffraction grating. The resultant diffraction pattern is displayed on the screen. The which change make the first order of the intensity maxima further apart from each other on the screen. So X is equal to lambda D over A. The fringe spacing is equal to lambda D over A. So here is which change makes the first order of intensity maxima further. We have to increase this X. So definitely for the increase in the X, lambda increase, D increases, mean the lambda increases, then X increases, or D increases, X increases, but when the slit separation or diffraction spacing, grating spacing decreases, this X increases. So these are the three options, either increase lambda, increase D, or decrease this spacing. So we will like placing the screen closer to the diffraction grating. No, we have to increase D. This is wrong. Using the diffraction grating with less separation between the adjacent, less separation mean A decreases. Yes, definitely when A decreases, X increases. So this is the option. And C is using the diffraction grating with more slits, but keeping the same separation between adjacent slides. Using the diffraction grating with more slits. More slits mean number of the slits more. Keeping the same separation. So when separation is same, there is no change in X. C is wrong. And using the light with a shorter wavelength. So definitely when wavelength decreases, X decreases. This is not the correct option. So B is the right one. Next question is 29. For a current carrying wire, the current can be calculated using the equation shown. I is equal to A and V cube. I is the electric current. A is the cross-sectional area of the wire. N is the number density, which is the number of the free electrons per unit volume. And V is the speed. V is the drift velocity of the electron. And Q is the charge particle, charge. So what is meant by N? The number of the charge carrier in the wire? No, it's the number of the charge carrier per unit volume. So wrong. The number of the charge carrier multiplied by volume? No, divide by volume. The number of charge carrier per unit length? No, wrong. So D is the option, per unit volume. Next, number 30 is the number of the free electron passing a point in a wire is in 24 hours is 6 into 10 power 23. So this is the number, not the number density. What is the average current in the wire? Look, I is equal to Q divided by T. And Q is equal to NE, where E is the charge of one electron, and this is the number of electrons. So when we will multiply the number of the electrons with the charge of each electron, charge of one electron, this is a total charge. So NE divided by T, number given, charge of the electron is fixed, 1.6 10 power minus 19, and the time is 24 hours multiplied by 3600. So answer is coming 1.1. That's why B is the answer. So this is question number 30.